Welcome to the DIY Honda Garage channel. The DTC B2965 refers to a rear communication failure in the Honda Odyssey models from 2011 to 2017. This issue typically arises in communication between the rear AC control unit and other components in the vehicle's HVAC system. The main components involved are the rear AC control unit itself, located in the rear section of the vehicle, and the HVAC control unit, located within the driver's dashboard area. The rear AC control unit is responsible for regulating the air conditioning settings for the rear passengers, while the HVAC control unit manages the full vehicle's heating, cooling, and ventilation functions. Faults can occur in the wiring or connectors associated with these units, leading to the DTC being triggered. The Honda Diagnostic System, HDS, is utilized for diagnosing this error, and resolving it often requires rigorous checks of electrical connections and the corresponding wiring. The DTC B2965 indicates a communication failure specifically linked to the rear AC control unit. The affected components are the rear AC control unit, which is responsible for controlling the air conditioning settings for passengers sitting in the back seats, and the HVAC control unit, which manages the overall heating and air conditioning in the vehicle. These units transmit signals back and forth, ensuring that the desired temperature settings are met conveniently by rear passengers. If there is a breakdown in this communication, it may manifest as functional issues with the rear AC system. This fault can often be traced back to problems in the wiring or connectors that link these units. Diagnosis usually involves using the Honda Diagnostic System, HDS, to check for any log trouble codes, which will help pinpoint the problem's source more accurately. Several potential causes could lead to the DTC B2965 being triggered. First, loose or corroded connections between the AC units and their wiring harness can prevent proper communication. Poor connections can lead to intermittent failures, which are often difficult to detect. Next, damaged or frayed wires within the harness may interrupt signals. These wiring issues can occur from wear and tear or from exposure to environmental factors. Lastly, a malfunctioning rear AC control unit or HVAC control unit itself could also contribute to this error code being logged. Each of these possible causes needs thorough examination during the troubleshooting process to ensure all connections are secure and that the components are functioning as intended. Symptoms related to the DTC B2965 will primarily affect the rear AC system's operation. One common sign is the rear AC becoming completely inoperative. The control unit may not respond to any inputs. Additionally, the vehicle's display may show error messages indicating a communication issue. Another possible symptom includes faulty temperature control, where the system does not provide the selected temperature settings effectively. In some cases, the dashboard indicators related to the HVAC system may also behave erratically, pointing towards a malfunction in communication between control units. Recognizing these signs early can assist in faster diagnostics and repairs, ultimately ensuring passenger comfort. The first troubleshooting step in addressing DTC B2965 is to clear any current diagnostic trouble codes using the Honda Diagnostic System, HDS. HDS is a specialized tool used for diagnosing and troubleshooting Honda vehicles. It provides a means to reset the vehicle's computer system after codes have been noted and before further diagnostics. Clearing the codes allows the technician to see if the DTC reappears or if it's just an intermittent issue. This initial step is crucial for creating a clean slate for further tests. Technicians should ensure that they're familiar with the HDS interface to effectively clear codes and navigate subsequent diagnostic options. After clearing the DTCs, the next step involves turning the ignition switch from the lock off position to the on authorization position. This process is essential to reinitialize the vehicle's electronic systems, including the HVAC control modules. By switching the ignition off and back on, it allows the onboard computers to perform a startup self-check and re-establish communication between components. This step often serves to reset any temporary faults and confirms whether the initial DTC was an isolated occurrence or if it persists. Ensuring the vehicle is in the proper state is essential before moving on to further diagnostics. Following the ignition reset, the next step is to perform a self-diagnostic function with the Honda Diagnostic System, HDS. This step assesses whether the previous DTC B2965 reappears and evaluates the overall condition of the rear AC control unit and the HVAC control unit. The HDS conducts a thorough scan of various vehicle systems to check for any related issues or additional diagnostic trouble codes. It is a critical component in providing comprehensive diagnostics, allowing the technician to understand if the initial fault is indeed persisting. The information gathered during this step will guide the technician in determining the next appropriate troubleshooting actions. After conducting the self-diagnostic function, the technician must check for DTCs again. This crucial step ensures that any new or reoccurring codes are noted, particularly focusing on DTC B2965. If the fault code reappears, it indicates that the communication failure persists, warranting further diagnostic steps. If no DTCs are present, it could suggest an intermittent issue, often related to loose connections or wiring faults. Properly recording this information is key for advancing to the next steps in diagnosing the issue thoroughly. In preparation for further diagnosis, the ignition switch should once again be turned to the lock position. This step is essential for the safe disconnection of any electrical components involved in the troubleshooting process, particularly before anyone attempts to access the wiring harness of the rear AC control unit. Proper safety measures always require the ignition to be off before making any electrical adjustments. This precautionary step helps avoid accidental shorts or disruptions during the next steps of the troubleshooting procedure. The next step is to disconnect the rear AC control unit connector B, specifically the 5P 5-pin connector. This connector facilitates communication and power supply to the rear AC control unit. By disconnecting it, the technician can further isolate issues related to connectivity or power delivery. The pin configuration allows for individual testing of the terminals, essential for diagnosing whether the rear AC control unit is failing or if the issue lies elsewhere, such as in the wiring leading to this unit. Ensuring this connection is correctly handled maximizes safety and efficiency during diagnosis. After disconnecting the rear AC control unit connector B, the technician must turn the ignition switch back to the on position. This action is necessary to supply electrical power while conducting tests on the disconnected connector. By turning on the ignition, it allows for checking the voltage at the connector terminals without having the rear AC control unit powered up. This distinct testing procedure helps ascertain whether the problem lies within the unit or the wiring. The HDS interface may still be used in conjunction with this step for supplementary information regarding electrical functionality. At this point, the technician should measure the voltage between the rear AC control unit connector B terminal number 1 and body ground. This is a crucial check for determining if there is battery voltage reaching the AC control unit. The 5P connector's terminal number 1 should have voltage consistent with the vehicle's electrical system when tested. If battery voltage is present, it would suggest that the connector and wiring leading to the control unit are intact. Conversely, if there is no battery voltage, it indicates a potential break or fault in the wiring. which would need immediate repair to restore communication functionality. Should the reading indicate no battery voltage at terminal number 1 of the rear AC control unit connector B, the next step is to repair any open circuit found in the wiring. This requires tracing back to locate the break, particularly examining the wire between the number C26 7.5 amp fuse located in the driver's under-dash fuse relay box and the rear AC control unit. A visual inspection can help identify obvious faults such as frayed wires or disconnected components. Once repairs are made, it's important to recheck the voltage levels to ensure the circuit is fully restored, confirming the issue has been effectively addressed before proceeding further. With repairs made to the wiring, the technician should turn the ignition switch back to the lock position. This step is essential for safety and to prepare for testing continuity in the next step. By ensuring the ignition is in the off position, it prevents any accidental shorts or system failures while measuring continuity. This action also allows for a clean slate when reconnecting any components for the next phase of testing. Following this procedural approach greatly reduces the risk of new errors entering the system due to ongoing diagnostics. At this final troubleshooting step, continuity must be checked between rear AC control unit connector B terminal number 3 and the body ground. This test assesses whether there is a complete electrical circuit, which is crucial for the operation of the rear AC control unit. A successful continuity check indicates that the internal pathways within the control unit are intact and that the unit can communicate properly with the rest of the vehicle's HVAC system. If continuity is not present, further investigation will be required to diagnose potential issues in the wiring or connector. It is imperative that this step not be overlooked, as it solidifies the completeness of the repair process before the vehicle is put back into service. After completing all troubleshooting steps, it is essential to perform a final repair verification to ensure that the rear AC system functions as intended. This verification process typically involves checking all temperatures and settings to confirm that the system responds correctly to inputs. The technician should also rerun diagnostics with the Honda Diagnostic System, HDS, to ensure no new or lingering DTCs are present. A successful verification ensures that the communication issue has been addressed and that the rear AC control unit operates in harmony with the HVAC system once again. This step serves as a closing check to guarantee that both safety and functionality have been restored. A preventive maintenance strategy for the rear AC system is vital in avoiding future issues like DTC B2965. Regular inspections of the wiring and connectors associated with both the rear AC control unit and the HVAC control unit can help catch faults before they escalate. It is advisable to periodically check for any signs of wear, corrosion, or loose connections. Keeping these components in good condition minimizes the risk of communication errors due to bad contacts or faulty wiring. Additionally, a periodic refresh of the vehicle's diagnostic data allows for early detection of any electrical anomalies. This proactive approach can prolong the life of the system and enhance overall vehicle performance. In summary, the DTC B2965 indicates a rear communication failure, affecting the rear AC system in Honda Odyssey models from 2011 to 2017. Effective diagnostics are crucial in identifying and resolving underlying issues, particularly in wiring connections and the control units themselves. Each step in troubleshooting must be executed methodically to ensure safety and accuracy in repairs. Addressing not just symptoms, but underlying wiring issues can prevent future occurrences of similar DTCs. Also, engaging in routine maintenance practices will enhance the longevity and effectiveness of the vehicle's HVAC system, ensuring passenger comfort. A comprehensive understanding of the system and proactive measures form the foundation of reliable vehicle performance. Please like and subscribe to the channel. See you next time.